Hello everyone, it's Richardson here, and in this video we will demonstrate how to visualize the molecular orbitals of a molecule using the WINMOSTAR software. Before that, let me go back to what we have done earlier. Okay, in Avogadro software, you just constructed a molecule and you just go to extensions and click the MOPAC and you run a MOPAC calculation using certain Hamiltonians, right? Okay, there you use a coding called GraphF, G-R-A-P-H-F, which is responsible for the generation of the MGF file when you go and perform the MOPAC calculation in the MOPAC software, and then you click and drag that MGF file into the JMOL software, and that is a Java programming software, and you can visualize all the MOs, okay, when you give the commands in the console window. Okay, but that's quite bit work which you did. But using the WinMoStar, it's very simple. You can do everything into this one single platform. Okay, so let me show how to do it. I'll just take an example of a salicylaldehyde to perform this. So now you can find your WinMoStar software open. I'll just select carbon to construct my ring first, the benzene ring. Click add atom, and you click on the screen. Okay, like that you do for 6 carbon atoms. Yes, just click it. Yeah, we have the 6 carbon atoms ready, and select the 2 circles, the red circles, and click add bond. Okay, the 2 should be selected, be careful in that. Okay, yeah, you have the bond, and then again see the 2 red circles, click, you have the bond. So similarly you do for all the atoms, connect the bonds so that you get the ring. Okay, yes, you have the ring now. Click add bond and the ring is ready. Now you need to put the bonds for benzene, the double bonds. Okay, let me select the 2 carbon atoms and click add bond and see a line. Okay, and that's the double bond, and again you do the same for respect to areas where you need the bonds. Yeah, now it's ready. Now before optimizing, you need to add hydrogens. Right click add hydrogen by selecting the carbons, click. Yes, you have add hydrogen. Yes, add hydrogen, add hydrogen. So 1 hydrogen for each carbon atom in benzene ring. Okay, yes, you got it. Now it's not nice, so let's optimize to get the stable geometry. Click it or Control G, you get the optimized geometry. Wow, it's very nice now to see. Now let me replace some fragments to get the salicylaldehyde. I'll remove 1 of the hydrogen. Remember, you select the 2 carbons with the carbon and hydrogen. Select the CHO fragment, replace. Yeah, see, you have the CHO fragment. Click 1 more hydrogen where you need to replace. Okay, and you select the OH group now. Before that, you need the 2 things to be selected, carbon and hydrogen, then only it will replace properly. Okay, the H group, now it's OH already we have selected. Click replace, and yeah, you have the salicylaldehyde. Click optimize. Yeah, it's optimized in the stable geometry. You see the coding generated right in the right side. See, you have the GraphF code there, so which we also used earlier. So this will be responsible for the MGF generation. And see, the Z matrix is displayed. Z matrix gives several details. See the number of the atom, then the element, the bond distance, and the bond angle, then the dihedral angle. All data can be obtained from the Z matrix, and see the XYZ coordinates are available for that molecule. Okay, now let me go perform the MOPAC calculation now. Okay, then I'll click the checkbox, configure window, and it opens the MOPAC setup. Now we need to set up the calculations. For A's, I go for easy setup. So it see a simple window appears. I select AM1 Hamiltonian, and the charge is blank, 0. Okay, no charge in this molecule. See, the multiplicity is singlet because all electrons are paired. Click the method as optimize and click OK. All your setup has been displayed in the main window, and now click run. You need to save the file. Before that, remember, all your files will be saved in the local disk C section. Okay, since your MOPAC is in your WinMoStar is installed in that disk. Okay, so don't change the location or else you'll get an error and no output will be displayed. Be careful. So I give the file name as salicylaldehyde. It will be saved in .mop format only, so don't worry. Okay, see, it's there, the MOPAC input file form. Then yeah, the program starts running in the command prompt. automatically. Yes, after completing, the MOPAC output file is ready in the notepad. See, within some minute, some seconds, you get the data. All the data are available, the bond length, the bond angle, and everything is displayed here, the Z matrix, Cartesian coordinates, and the necessary data, filled levels, and everything. See, and finally your MOPAC calculation is done. See, all our very good calculations have been performed. See, the Mulliken charges are displayed. See, you can just select the Mulliken charge and that will give you the charges on each molecule. Okay, so you can get the electronegativity data and you can see the number and element. It's displayed. See, or number of carbon atoms are there. You can, for reference, in the Z matrix. Go to analysis icon, you click MO and density MGF. Get a file, you need to save it in the .mgf format. It's showing the name, local disk C, and you click open. Okay, it will open a new window. A dialog box appears. Yes, you see all your homolumos displayed, the molecular orbitals. See, 1 to 42. Totally you have 42 molecular orbitals, right? And you see total number of homos 23. Right, so totally you have 23 homos and the remaining are your lumos. Okay. Yes, and you can see the homo-lumo gap displayed, right? If I select one and you see the homo-lumo gaps all displaying over here. Okay, I'll show you how to adjust this scale so that you can visualize properly. It's an atomic unit. Let me change to electron volt. Yes, it's changed now. Okay, see, you can see all, select it and you see the red line, right? So when I select that, the red line appears and that is the respective molecular orbital for that. Okay, one is not showing. I'll just offset it. Use the offset and I just adjust it. Yes, okay, yes. Now it's visible. All are clear now, right? C2, the red line, 3, then you see the 5, it's showing there. See, the homo-lumo gaps are displayed as you click the orbitals properly, right? That's a very nice and wonderful information we get over here in the energy level dialog box. Okay, that's all about this one. You have the Excel option. You can export the homolume energy data to your Excel and plot it in different page. You have the MO plot dialog box here. Select MO in the quantity. Okay, so that we will visualize the MO. Okay, let me select any one of the molecular orbital which I want to visualize. Okay, I have the 23, the last homo. I click show diagram. See, in the diagram it shows the homo is shown there, right? See, the red line is showing there. Okay, and use the options what you want. I'll just go click draw. Yes, yeah, now it will calculate the isosurface. After the isosurface is being calculated, see, the WINMOSTAR viewer opens. It's inbuilt, okay, in the while you install WINMOSTAR software. Okay, so you have the data. Yeah, the MO is visualized properly. It's very nice to see. And now you can go to anything. Okay, I'll just click some other molecular orbital. Okay, something. Okay, yeah, you can see that. Okay, the 23 is displayed. Sorry, and okay, let me select. So I'll select 27. See, the red line is showing there. 25, everything, and just see it's showing and click draw. Calculating the isosurface, and yeah, it's displayed. See here, so you can find your molecular orbital displayed. You can export the JPEG format and you can also do some editing. See, I'll just click white background color and you get the white background. It's clear view, and the representation, molecular representation, the space filling model, stick model. See, all the atoms and things, molecules in stick model. And in the WINMOSTAR viewer it's black only. Let me go with the WINMOSTAR. Okay, the blue screen is displayed there. See, a little drag, it will give you. If you give solid and you can click draw, and you see it will show a solid view. Yes, see, it's very nice. You can also change the background color. I'll go to white. Yeah, now it's nice. So you can zoom it. Yeah, it's showing very nicely, right? Okay, you can select the transparency option and everything, click draw, and you will get the different kinds, whatever you want, like that. Okay, that's what you have to do it. Okay, thank you. Okay, so let us see what more can be done under that MO visualizing. Since we had many options, I'll just have the same molecule. In the analysis, click the MO and the density, and yeah, the file will be generated as we saw earlier. Yeah, you got this diagram, right? In that you saw that MO we did for MO. Let's see, look upon the other options. Okay, so here I'll go with the surface now. So let's see the surface of the molecule. Okay, all the details will be explained in the theory. It's already available. We'll just provide you the link below. Yeah, so here you can see in the WINMOSTAR view, you can find the surface of the molecule generated, right? And you have the electrostatic potential map, which shows the population charge. Okay, we'll also give the link what is the electrostatic potential map. Okay, yeah, this is how it looks, right? The population charge, so that has been displayed for the molecule. And then you can go to find both electrostatic potential map and the surface both displayed. So you'll have to generate a cube for that, so it is automatically generated. You click there. Yeah, now you can click draw. So after calculating the isosurface, you get it. See, you are getting a beautiful electrostatic potential map with the surface charge and everything. And the concepts are explained clearly. We'll provide the link in the description. Please see that to get what is the electrostatic potential map. Okay, let's visualize the MO surface for some orbitals now. Same way, I'll select the MGF file for the same molecule. Okay, yeah, you can find the thing here. And you just select MO surface. Okay, so I will select a molecular orbital. For example, say I select number 42, molecular orbital number 42. Yeah, it's shown there. And finally you generate cube. So you can see the MO surface now for that particular molecular orbital. Okay, then yes, yeah, so now the WinMOS mo.cube file is generated. You click map and you just click draw. And see, after calculating the isosurface, you get the MO surface of the molecular orbital number 42. See how it is? The red, blue, green areas indicate the electron density values, so which is explained in the in a video which will be displayed in the description. Okay, you can look over there for theory.